Good day, everyone. Today we will going to report the process management, just-in-time, and total quality management. I am Carl Josar Imboc, together with Angeline Jumawan, Gampay, and Amy Ugsod. Lean manufacturing and the Kaizen philosophy at Mars. So when we say Kaizen philosophy, it is a concept of creating small positive changes. So it is also an attitude based on cooperation and commitment. So the Kaizen cycle or the Kaizen philosophy includes the Kaizen cycle, which is involving employees identifying problems, creating a solution, testing the solution, analyzing the results, standardizing the concept, and adapt to the changes of the society. So that is what Kaizen cycle is all about. But when we say lean manufacturing, it is equivalent of removing waste. So eliminating waste is certainly a key element of any lean practices. So that is what a lean manufacturing. So as an introduction, as already discussed in earlier chapters, supply chain management is all about achieving low cost along with high levels of quality and responsiveness throughout the supply chain. Customers today expect these things, make it necessary for firms to adopt strategic initiatives emphasizing speed, innovation, cooperation, quality, and efficiencies. So in these times, firms will turn their practices into sustainable ones. So as a consumer, mas piliin mo sa mga consumer ang quality, diba? So ang mga firms nagapangita po pamaagi nga ila pong i-improve ang ilahang services para mag-produce mga products. So we have the lean production and the Toyota production system. So the Toyota production system is a production system systematizing the way of thinking and the management techniques to improve a company's competitiveness. And by the way, the term lean production is essentially refers to the Toyota production system and its entirety, a system that was created by several of Toyota's key executives over the number of decades. So as what I said earlier, lean production is about eliminating waste. So through the elimination of waste, Toyota production system wants the best quality, the shortest lead time, and the lowest cost are aspired sa ilahang company. So they have the way of thinking to get a competitiveness and a systematic techniques developed by making efforts for many years. So the story begins at the 20th century as typified the Ford Model T. So the mass production era began in the United States and the demand of the mass production is very high, but in Japan, which is Toyota is located, the market size was very small, so they cannot keep up sa demand sa consumers. So Japan want to catch up with the United States. Therefore, the people of Toyota Motor Corporation kept thinking how the cost could get cheaper, but at the same time, in a small lot production, makaproduce sila og daghan na products. So they want to improve its competitiveness. That's why their efforts of their predecessors developed the lean production, so could be applied, and it could be applied to any mass production. So in summarization, the Toyota production system is the idea systematizing the concept and the method to improve a company's competitiveness, a production system to respond to the consumer's needs in a small lot production of many products, and not completed but has been developing. So they are still developing their ways sa ilahang company. So the lean thinking and supply chain management, the objective of supply chain management is to balance the flow of materials with customer requirements throughout the supply chain, such that cost, quality and customer service are at optimal levels. Lean production emphasizes the reduction of waste, continuous improvement, and the synchronization of material flows from within the organization and eventually including the organization, tier, first suppliers, and customers. So we have here the lean thinking and supply chain management. So the supply chain management evolution includes the stages, which are the internally focused, functional integration, internal integration, and external integration. So the internally focused includes functional silos, top-down management. When you say functional silos, it is in a business that are teams of employees grouped by function that all operate separately from each other without cross-collaboration. So it also includes the top-down management, which occurs when goals or projects and tasks are determined among your company's senior leaders or usually independently of the team. So the top-down approach goes from the general to the specific, and the bottom-up approach begins at the specific and moves to the general. So internally focused also includes internal measures used to monitor performance, communication capabilities. So we have here the next one, the elements of lean. As what I said earlier, lean manufacturing is focused on eliminating waste. So the first one is the waste reduction. The next one is lean supply chain relationships. The firm's relationships to the customers and to their partners. Next is the lean layouts of how they will do the practices to their firm, the inventory and setup time reduction, small batch scheduling, continuous improvement, and the last one is the workforce empowerment. We have here the 7 wastes: overproducing, waiting, transportation, overprocessing, excess inventory, excess movement, and scrap and rework. The next one is the using of the 5S to reduce waste. So the first one is sort, the second one is to set in order, sweep, standardize, and self-discipline. So these 5S can be used to reduce waste. The lean supply relationships. So quite commonly, firms must hold safety stocks of purchased products because their suppliers' delivery times are inconsistent or the quality of the purchased goods do not always meet specifications. So for a supply chain to work efficiently, it is both the client and the transporter's responsibility to keep open air waves to collaborate, solve challenges, and share a new worsening development with one another. So that is very crucial to the lean supply relationships.
So good morning, this is the continuation of the report of Mr. Imboc. So lean layouts. The primary design objective with lean layouts is to reduce waste and movements of workers, customers, and our work in process, or what we call WIP, and achieve smooth product flow through the facility. Moving parts and the people around the production floor does not add value. So lean layouts makes work easier, faster, and more convenient to reduce the labor needs or workers. So example, ang is facility sa Pinyahan na they have a U-shaped layout where ang first sa edge sa pinaka-first nga edge sa U is ang paghugas sa pinya, hanggang maabot siya sa pika sa edge, which is the last step sa pag-clean sa pineapple. And then another example is the office layout where printers and computers dapat or photocopiers is naa sa room where naa dito mga workers nga gagamit sa photocopiers, scanners, and printers more compared sa uban nga workers. So dili pwede nga magdagan pa sa example sa second floor para dito mag-print. So dapat ibutan siya sa specific na room where naay gagamit og workers ana nga product. Next is manufacturing cells, also called as work cells, designed to process any parts, components, or jobs requiring the same or similar processing steps, saving duplication of equipment and labor. Manufacturing cells are also used to increase the efficiency of the flow of materials and to eliminate waste in the manufacturing process. For example, overproduction is an example of a waste because more products are made than can be used. A manufacturing cell eliminates waste by making it easier to produce only what is needed. All operations are in close proximity and the production process is simplified. In cellular arrangement, one operator can complete multiple operations, which may improve the balance of work and simplify product flow. The next one is inventory and setup time reduction. So we have here a picture, and it is a relationship between order quantity, lot size, and average inventory. So inyuhan na siyang tanawon, guys. And then in lean parlance, excess inventories are considered a waste since they tend to hide a number of purchasing, production, and quality problems within the organization. For example, is reducing safety stocks of purchased materials will cause stockouts and potential manufacturing disruptions when deliveries occur. So firms must find a way to resolve the delivery problem or find a more reliable supplier. So you have here figure 8, and you can just tanawon kung saan na there. Like for example, when order quantity is, or lot size is Q is equals to 100, average inventory is equals to 50. When Q is reduced to 50, average inventory falls to 25. So you can study it later. So next is small batch scheduling. Saying the manufacturer should purchase small quantities more frequently from good suppliers and should produce items using small lot sizes with more setups is one thing, but actually accomplishing this feat is something else. So you have their figure 8.2, which has like small lot size increases flexibility. So an example, that's a small lot size approach and it's a large lot size approach. Mo siya ang product changes niya. And then the other figure is Kanban pool system. So dara you have work cell A and then the work cell B. So makita niyo mga arrows dira. Studyhan niyo siya later. So the next one is continuous improvement. As alluded to already, lean systems are never-ending works in progress. Compact layouts are designed to allow work to flow sequentially and quickly through the facility. Inventory is moved from supplier delivery vehicle to the shop floor and placed in containers in designated work cell storage areas. So, continuous improvement can add in process, commitment, strategy, and performance. So now we have the Lean Six. A term is now being used to describe the melding of lean production and Six Sigma quality practices. It is called Lean Six Sigma or simply Lean Six. In 2009, for example, the U.S. Navy commissioned the nuclear aircraft carrier USS George H.W. Bush, built by global security company Northrop Grumman using lean manufacturing and Six Sigma extensively to improve quality, reduce costs, and shorten cycle time. Since 2007, the U.S. Defense Department's Lean Six Sigma office has completed more than 330 projects and trained more than 1,000 officials on the techniques of Lean Six, allowing them to take on new projects themselves. So now we have the Six Sigma and supply chain management. By now, the supply chain management objectives of better customer service, lower costs, and higher quality should be starting to sound familiar. To sustain and improve competitiveness, firms must perform better in these areas than their competitors. Through better process integration and communication, trading partners along the supply chain realize how poor quality products and services can cause negative chain reactions to occur, such as greater levels of safety stock throughout the supply chain, lost time and productivity due to product and component repairs, the increased cost of customer returns and warranty repairs, and finally, loss of customers and damage to reputation. And the next topic is lean systems and the environment. Many organizations have realized the positive impact lean systems can have on the environment. Adopting lean practices reduces waste, the cost of environmental management, and also leads to improved environmental performance.
So good day everyone, I am Amy and I will be discussing to you about the 6 Sigma and its element. So the Deming's contribution. So W. Edwards Deming's theory of management, as explained in his book, Out of the Crisis, essentially states that since managers are responsible for creating the systems that makes organization work, they must also be held responsible for the organization's problem. So only management can fix problems through application of the right tools, resources, encouragement, commitment, and cultural change. So Deming's died in 1993, and Deming's theory of management was the centerpiece of his teachings around the world, and includes his 14 points for management. So now here is the Deming's 14 points for management. So first is the create constancy of purpose for improvement of product and service. So create a constant purpose toward improvement. So they must plan for quality in the long term and resist reacting with short-term solution, and don't just do the same things better. Find better things to do. Next is the adapt the new philosophy. So adapt to the new philosophy. Embrace quality throughout the organization and put your customers' needs first rather than react to competitive pressure, and design products and services to meet those needs. Next is cease dependence on mass inspection. So stop depending on inspections. So inspections are costly and unreliable, and they don't improve quality. They merely find a lack of quality. Next is end the practice of awarding business on the basis of price tag alone. So use a single supplier for one item. So quality relies on consistency. The less variation you have in the input, the less variation you'll have in the output. And look at the suppliers as your partners in quality. Encourage them to spend time improving their own quality, and they shouldn't compete for your business based on price alone. Next is constantly improve the production and service system. So improve constantly and forever. So continuously improve your systems and processes. Then we promoted the plan, do, check, act approach to process analysis and improvement. So emphasize training and education to everyone so everyone can do their jobs better. Next is institute training. So use training on the job. So train for consistency to help reduce variation and build a foundation of common knowledge, and allow your workers to understand the rules in the big pictures. Next is adapt and institute leadership. So implement leadership. Expect your supervisors and managers to understand the workers and the process they use. Don't simply supervise, but provide support and resources so that each staff member can do his or her best and be a coach instead of a policeman. So next is drive out fear. Eliminate fear. Allow people to perform at their best by ensuring that they're not afraid to express ideas or concerns. Let everyone know that the goal is to achieve high quality by doing more things right, and that you're not interested in blaming people when mistakes happen. Next is break down barriers between departments. So break down barriers between departments, build the internal customer concept, recognize that each department or function serves other departments that use their output. Next is eliminate slogans and exhortations and targets for the workforce. So get rid of unclear slogans. Let people know exactly what you want. Don't make them guess. Excellence in service is short and memorable. But what does it mean? How it is achieved? And the message is clear in a slogan like, you can do better if you try. And next is eliminate numerical quotas for workers and managers. So eliminate management by objectives. So look at how the process is carried out. Not just numerical targets. Deming said that production targets encourage high output and low quality. Next is to remove the barriers that rob people of pride of workmanship. So remove barriers to pride of workmanship. So allow everyone to take pride in the work without being rated or compared. And next one is to encourage education and self-improvement of everyone. So implement education and self-improvement. So improve the current skills of your workers and encourage people to learn new skills to prepare for future changes and challenges. And lastly is to take action to accomplish the transformation. So make transformations everyone's job. So improve your overall organizations by having each person take a step toward quality. So yes, that's the Deming's 14 points for management. Next is the cross-based contribution. So the cross-based contribution is the contribution of Philip Crosby, a former vice president of quality at the New York-based manufacturer ITT Corporation, was a high sought-after quality consultant during the latter part of his life and wrote several books concerning quality and striving for zero defects. So his findings about quality improvement programs as discussed in Quality is Free, where that these programs invariably more than paid for themselves. So the Crosby's for absolute quality is that the definition of quality is conformance to requirements. The systems of quality is prevention. The performance standard is zero defects, and the measure of quality is the price of non-conformance. So the definition of quality is conformance to requirements is that adopt a do-it-right the first time attitude and never sell a faulty product to a customer. And the next is the system of quality is prevention. So use SVC as part of the prevention system. Make corrective changes when problems occurs and take preventive action. Next is the performance standard is zero defects. So insist on zero defects from suppliers and workers. Education, training, and commitment will eliminate defects. And lastly is the measure of quality is the price of non-conformance. So the price of non-conformance is the cost of poor quality. So implementing a prevention program will eliminate this. Next is the Duran's contribution. So Duran's contribution, Joseph Duran, founder of the Duran Institute, helped to write and develop the Quality Control Handbook in 1951 and now in its 5th edition. So he was born in 1904 and Duran remained an active lecturer until his death in 2008 at the age of 103. So now here's the Duran's Quality Trilogy. The 3 Duran's Quality Trilogy: the Quality Planning, the Quality Control, and the Quality Improvement. So next is the Malcolm Baldrige National Quality Award. So the U.S. Baldrige Quality Award was signed into the law on August 20, 1987, and is named in honor of then U.S. President Reagan, Secretary of Commerce, who helped draft an early version of the award and who was tragically killed in a rodeo accident shortly before the award was enacted. So the Baldrige Award is administered by the National Institute of Standards and Technology, or the NIST, and is presented by the President of the U.S. each year to small businesses, service and manufacturing firms, and educational, healthcare, and non-profit organizations that are judged to be outstanding in 7 areas. It includes the leadership, the strategic planning, the customer and the market focus, the process management, and the result. So now, you can see the up to 3 awards can be given annually in each of the categories, and these are the Baldrige Award winners from 1988 throughout 2009. So next is the ISO 9000 and 14000, so families of management standards. So in 1946, delegates from 25 countries met in London and decided to create a new international organization with the objective to facilitate international coordination and unification of industrial standards. So the new organization, called the International Organization for Standardization, or the ISO, officially began operations on February 23, 1947. Now located in Geneva, Switzerland, the ISO today has 159 member countries. So in 1987, the ISO adopted the ISO 9000 series of 5 international quality standards and revised them in 1994 and again in 2000. So the standards have been adopted in the US by the American National Standard Institute, or the ANSI, and the American Society for Quality, or the ASQ. The standards apply to all types of business, and in many cases, worldwide, companies will not buy from suppliers who do not process in ISO 9000 certification. So yes, that is the ISO 9000 and the 14000. So next is the DMAIC improvement cycle. So it shows in this slides the 5 steps of DMA-IC improvement cycle. It is an important element of Six Sigma, listing the sequence of steps necessary to drive process improvement. So the cycle can be applied to any process or project, both in services and manufacturing firms. So the improvement cycle begins with customer requirements and then seeks to analyze and modify processes or projects so they meet those requirements. So the 5 steps are the define, measure, analyze, improvement, and the control. So using the DMA-IC improvement cycle allows the firm to continuously monitor and improve processes that are keys to customer satisfaction. So by concentrating on these key processes and the CTQ characteristics, firms can make large radical improvement in process, products, and customer satisfaction. So next is these are the 6 Sigma training levels: the yellow belt, the green belt, the black belt, and the master black belt. So you can read all those. So next is the flow diagrams. So flow diagrams, also called as the process diagrams or process map. These tools is necessary first step to evaluating a manufacturing or service process. So the flow diagrams are used to annotated boxes representing process actions, elements, and ovals representing wait periods, connected by arrows to show the flow of products or customers through the process. So once a process or series of process is mapped out, then potential problem areas can be identified and further evaluated for excess inventories, wait times, or capacity problems. So so in this figure 8.5, it shows an example of a customer flow diagram for a restaurant. Next is the check sheets. So the check sheets allows users to determine frequencies for specific problems. And for the restaurant example shown in the last slide, managers could make a list of potential problem areas based on experience and observation, and then direct employees to keep counts of each problem occurrence on check sheets for a given period of time, long enough to allow for the true problem level determination. So at the end of the data collection period, problem areas can be reviewed and compared. So it shows in the figure 8.6 that a typical check sheets that might be used in a restaurant. So Pareto charts. So Pareto charts are useful for many applications and are based on the work of Vilfredo Pareto, a 19th century economist. So the charts are useful for presenting data in organized fashion, indicating process problems from most to least severe. It only makes sense when utilizing a firm's resources to work on solving the most severe problems first. So here is, I can see the figure 8.7, the Pareto charts for restaurant problems. This is the example of a Pareto charts. So next is the supply chain report. So once a problem has been identified, the cause and effect diagrams, or also called fishbone diagram or the Ishikawa diagrams, can be used to aid in brainstorming and isolating the causes of a problem. So it shows in figure 8.8 that illustrates of a cause and effect diagram for the most troublesome long wait problems of the last figure 8.7.
Will be the end of my report. Thank you.
Proceed to the cause and effect diagrams. So it is called as a fishbone diagram or Ishikawa diagram. So it is used to aid in brainstorming and isolating the cause of the problem. So when the problem is identified, pwede na rin ito magamit ng diagram. So as you can see in the figure 8.8, it shows the cause and effect diagram for the long wait problem. So as you can see in the image, material, machinery, methods, and manpower are the causes, while the field under that cause, like as you can see kanang mga arrow, like run out of food, like materials na example lang, not enough tables, late deliveries, and inadequate waiting area is mo na siya ang effects. So importante kining cause and effect diagrams kung mag-identify ta og isa ka problem. Next is statistical process control. It allows firm to visually monitor process performance, compare the performance to desired levels or standards, and take corrective steps quickly before process variabilities get out of control and damage product, services, and customer relationship. So once ang isa ka process is working correctly, we can create the control chart. So it is control chart is a graphic representation of process performance over time, showing the desired measurement, the center line of the control chart, and the process's upper and lower control limits. So kanisha is a visual aid that helps the operators or other workers to plot data very easy. And next is variation. In process measurement can be either natural variation or assignable variation. If the natural variation are present, so magamit taan ng statistical control. Pero kung ang assignable variation is present, so magamit taan ng og causes. Next is the samples. So because of the process of variation in the process measures, sample of data are collected and the sample means are then plotted into control charts. So there are naay duha ka na bilang sa samples which are the variables data and the attributes data. The variables data are continuous, such as time, weight, and length. Attributes data indicates the presence of some attributes such as color, satisfaction, workability, or beauty. So, example of variables data would be the time kung kano sa gi-serve sa waiter ang pagkaon sa customer, or kung say weight sa box sa cereals or length sa steel rod, while the attributes data is kanang kuan bitaw if nasatisfied ba ang customer sa ihang gikaon, like that. So next is the variables data control charts. So there are two types of control charts. The X chart, it is used to track the central tendency of the sample means, and the R chart is used to track sample ranges. So as you can see in the image there, the first step in constructing any control chart is to gather data. So ang formula is kung magkuha ta og the central lines sa X chart and R chart are nadira sa image. And then kung mag-calculate pud ta og kanang ang iyahang upper and lower control limits for two control charts is mo na nimo gamiton nga formula kanang UCL equals X chart plus A2 times R chart. So as you can see in the example 8.2, these are the variable control chart data for soup cans of Haley Girl Soup Corporation. So the Haley Girl Soup is a soup manufacturer has collected process data in order to construct control charts to use in their canning facility. So sa isa ka oras, ang ilang X chart is nakakuha sila og 11.88. Ang i-total na siya sa 24 samples, 24-hour period man. So ang ihang mean kung i-add na siya tanan is 11.96, while the R chart is 0.39. Next is the table 8.11, the constant of computing control chart limits. So muna siya, sample size is 2, mean factor niya is 1.88, and then the UCL and D4 is 3.268, and LCL is 0. So that's how you compute control charts limit. And then muna din siya ang variables data control charts kaning figure 8.9. Katong ingon ako sa inyo nga ang control chart is very easy para sa mga operators or other workers to plot their data. So as you can see in the figure, ang kani siya is gina-plot na siya kung example katong isa ka oras is 11.9, isa magtulo na ka oras is 11.8. So that's how you plot the data. The same with the R charts. Next is the attribute control charts. So P charts is the percent defective and C charts is the number of defective. So kung mag-use na ta or mag-construct na ta og P charts is mo ni ato ang gamiton nga formulas nga as the image shown there. So kanang P equals to is muna siya ang formula sa P chart. So that's it. So next is using and constructing P charts. So example ni siya sa P charts. So murag yapon to day 1, ang iyang fraction defective is 0.01. Day niya 16, fraction defective is 0.04. And then using C chart, example 8.4, monitoring editorial defects and at Cassie Publishing Incorporation. So 8 editorial assistants are monitored for defects in the firm's printed work on the monthly basis. So muna siya. That's how you compute the C charts. Next is acceptance sampling. Can be used whether or not a shipment will be accepted, returned to the supplier, used for billback purposes when defects are fixed or units are eliminated by the buyer. So kaning acceptance sampling is very effective ni siya kay basta hindi ay ang isa ka supply is daot. So naran sa inyo if inyo ba dawaton or ibalik niyo sa supplier. Next is the statistical process control and supply chain management. So ideally, long-standing strategic supply chain partners would not need to monitor their inbound and outbound product quality. Quality would already be extremely high and employees could spend their time in more productive pursuits. So dili man jud perfect ang processes and suppliers. So kailangan gyud nila nga and ang industry is daghan kayo og competition. So kailangan gid nila nga ma-identify ang processes critically para ma-achieve nila ang ilahang objectives sa ilahang company. So that's the end of our report. Thank you so much for listening.